Welcome to our lesson on the sine law. So in the past, when we were trying to find an angle or a side, we would use either our SOHCAHTOA or our Pythagorean theorem. So the sine law is okay for right triangles, but I wouldn't suggest you use them. These are mainly for non-right triangles. And we can find the side or an angle of a non-right triangle using the sine law. So the following here is the sine law. Now it says or, so you can use either one of them. I tend to use this one more, so all the examples you're going to see are in sine A over A is equal to sine B over B is equal to sine C over C. So what does this sine A over A mean? What does it look like on a non-right triangle? So here is a triangle that it does not have 90 degrees. I'm just going to label the vertices as ABC. So this ABC describes the angles at that point. And the little a, little b, little c are describing the sides. So directly across from angle A, you're going to find side A, denoted as little a. Directly across from angle B, you're going to find side B, which is denoted as little b. And lastly, directly across from angle C, you're going to find little c, which is your side C. So that's the relationship between the angles and its sides. Now, we only use a sine law for a specific type of questions. If we know two sides and one angle that is directly across from the side, then we can use a sine law. In other words, this is called side-side angle, as SSA, side-side angle. Whenever we see this in a triangle, we can use our sine law. Or we could also use it when we have two angles and any side. So we have AS, so that's angle, angle, side. And lastly, angle, side, angle, ASA. Then we know that we can use our sine law. And other points to note, if you know the measures of two angles in a triangle, you can also use the rule that all three angles in a triangle is going to add up to 180. So to determine the third angle, you just do 180 minus all the other angles. So for example, angle C can be found by taking 180, subtracting angle A and angle B to it. So when determining side lengths, it's more convenient for you to use A over sine A equals B over sine B. And when determining angles, it's more convenient to use sine A over A equals sine B over B. Again, it really doesn't matter in the end as long as you follow through with knowing how to solve and using your rules for solving equations, then it doesn't matter which one you use. But if you do want an easier, slightly easier way to solve for your missing angle or side, then you can follow these bullet points here. Okay, so let's go ahead and apply these to actual questions. For our first example, we've been given the picture of the triangle GHJ, and we want to determine the length of GH. So GH is just from here to here, which is also side J. So in other words, we're also looking for side J, and it's a length. Let's take a look at the information that is given to us. We have angle G, which is 51 degrees. We have angle J, which is 44 degrees. We have side G, which is 7.8 centimeters, and then we're looking for side J. So with this information, we can use sine G over G because I have information for both of our G's, the angle G and the side G. And we also know the angle J. We just need to find side J. So I'm going to use this following formula. Sine G over G is equal to sine J over J. I'm going to fill in our information. So angle G is 51 degrees. Our side is 7.8 for G. Our angle J is 44 degrees. And our side J is what we're looking for, so I'm going to leave it as J. Now this next step is very important, and you're going to use this step every time you use the sine law. We are going to cross multiply. Because we have a fraction equals a fraction. It's just kind of a shortcut way for us to solve for our missing variable. So that means the J is going to multiply with sine 51. That's why I have those arrows. The arrowhead indicates which one I'm going to multiply it with. And then I'm going to multiply the 7.8 with the sine 44. So remember that sine 51 and sine 44, they are just numbers that you can punch into the calculator. So I'm trying to solve for J. I'm going to now divide to get J by itself, which means that I'm going to divide by sine 51 on both sides. And this is what we're going to put in the calculator. So the last step for us to do is punch this into the calculator. Please be careful when you do this, because I've seen students plug it into the calculator incorrectly and then you end up getting the wrong answer. So what you can do first is punch in sine 44 in the calculator. Try to keep as many decimal places as you can if you're writing it down, and same with sine 51. But your final answer should be 6.97, and our units are in centimeters, and that would be your final answer. So please try to punch this into the calculator right now to see if you can get the same answer as me, because if you don't, then you're going to have to fix your method in using your calculator. But again, it's maybe easier for you to find sine 44 first. Write that answer down somewhere, try to keep as many decimal places as you can. Then find out what sine 51 is. Write that answer down, keep as many decimal places as you can, and then punch in your calculator like that. Also remember to keep your calculator in degree mode and not radians or the grade mode. Here's another example. This time you want to find an angle instead of a side. So we're given the triangle MNP, and we're looking for angle N in here. So here's the information that we have. We have angle M, which is 92 degrees. We also have side M, which is directly across from angle M. This is 11.8 centimeters. And then lastly, we have side P, which is 10 centimeters. The thing is, we want to find angle N, and in order to use the sine law right away, we would have to find some sort of information about N, or side N, which you don't know. With this information, all I can really find is angle P. So that's what we're going to do. And once I have angle P, I can find angle N afterwards. Again, we're finding angle P because that's the only information that we actually can find right now. We have no information about side N or angle N. So then I'm going to use a formula. sine m over m is equal to sine p over p. Then we're going to fill in our information. Angle m is 92 degrees, side m is 11.8. We don't know what angle p is, we're trying to solve for that, and side p is 10. Now our step to solving here is really important. We're going to do the same method as before. We're going to cross multiply when we have a fraction equals a fraction. That means the arrowhead here with the sine 92 is going to multiply with the side 10 down there. So your arrowheads indicate what we're going to multiply each other with. So you have 10 sine 92 degrees is equal to 11.8 sine p. We want to get p by itself. So in this case, I'm going to divide both sides by 11.8, and that's because there is a number here besides sine p, and I want to get p by itself. Because now this 11.8 divided by 11.8 is gone. So sine p then is equal to 10 sine 92 divided by 11.8. So I'm going to go ahead and plug this into the calculator. I'm going to find sine 92 first, press equals, multiply by 10, press equals, then divided by 11.8. And once I do that, I'm going to get this long decimal number, and I'm going to keep all my decimal places in. Again, at this step, I really want you to punch this into your calculator right now to make sure that you can get the same number as me. Then our final step here, to get angle P, take the sine inverse of both sides. Because the sine inverse and the sine are going to cancel out because they are opposites of each other, and then we're just going to be left with angle P. So this is gone. Angle P is sine inverse of 0.849413788. And then we're going to put that into our calculator. Remember, to get sine inverse, you're going to press second function sine. And we should get about 58 degrees if we round to the nearest whole number. So we finally found angle P. Remember, in the original question, we're trying to find angle N. But we know that all three angles in a triangle must add up to 180 degrees. So just a side note here. They have to add up to 180 degrees for triangles. So I'm going to take 180 subtracted by the two angles, which is 92 degrees from the original question and from the angle we just found, which is 58 degrees. Our final answer then is 30 degrees, and that is angle N.